So now let's talk about reciprocal functions for a second. And this doesn't have this won't have as much variety in terms of end behavior, so it'll be a little more straightforward and like not as much to kind of juggle in terms of like, is it even, odd, negative, all that you'll see kind of works itself out in a pretty nice way. So this is the parent function of the reciprocal function, which is you have this situation where you have a hyperbolic situation where you have these two parts that kind of that go away from one another. So you have one part in one quadrant, another part in the in another quadrant, kind of the opposite quadrant. And so anyway, what happens as we go right forever is this gets closer and closer to zero. And what happens as we get left forever is this gets closer and closer to zero, right? Now they get closer and closer to zero from different sides, but either way they get closer and closer to zero. So the limit of as x approaches infinity or negative infinity of a reciprocal function, 1 over x, equals 0, okay? No matter whatever side you come from, all right? Okay, so let's kind of generalize this a little bit more. So here we have kind of a modified reciprocal function where we have a is just some constant, okay? And n is the degree, but in this case it's even. If it's even, instead of having something that's down in this negative portion here, it'll be positive, right? Everything, when you raise something to a even power, it'll be positive. And so it's going to go up and up forever. But remember, we're worried about, in this lesson, and when we talk about limits to infinity, we're talking about what happens as we go right forever and what happens as we go left forever. And so in this case, once again, everything approaches 0, right? So the limit as x approaches either positive or negative infinity of a to the x over n, where n is even, is going to equal 0, right? Okay, even if a is negative, right? Let's say a is negative, a is less than 0. It's still going to be upside down. But as we go right and left forever, we're still approaching 0, right? We're approaching from the bottom instead of from the top. So our numbers, as we plug in numbers that that get really, really large here, we'll have a constant over those really, really large numbers, which gets us really, really close to 0. So if this happens to be negative, we'll have like really negative numbers that are really small. We call those negative infinitesimals. And if a is positive, like we see up here, then we're going to have positive infinitesimals, right? We're going to get really, really small, like 0.01, 0.0001, 0.000001, those kind of numbers. And it might not be a 1 at the end, but it's going to be a lot of zeros between the point and what comes next as you keep going, as you keep plugging in numbers that get larger and larger here, okay? All right. And so if n is odd, you're going to have, what we saw initially with the parent function. You'll have that situation going on. But still, once again, everything's approaching 0, right? So this is still true even if n is odd, right? And even if a is negative again. Oh, I just realized I messed this one up. I meant to say negative less than 0, right? So if a is negative, everything's going to flip upside down like we saw above. Okay. But same thing, still approaching 0, right? We're approaching from different sides, but we're still approaching 0. So this holds anytime you have an a over x to some power. So anytime you have a constant over x to some power, even if it's to the first power, no matter if a is positive or negative, no matter if n is even or odd, you're always going to approach 0. Okay, so that's something you can remember. So once again, you don't have to think about, if you have x in the bottom and a constant on top, you don't have to think about the signs or think about even or odd in terms of the degree or the exponent. All you have to do is just remember it's going to go to 0. So right here, anything like this, I already know it's going to go to 0, right? And let's think about it in terms of just computationally, like if we were to do a table, if I were to plug in numbers that got bigger and bigger with the x. Like, even though I have a pretty big number on top, 920, it's not going to be significant when we get towards infinity, right? When we get closer to infinity. So, like, let's just start with a million. 16 times a million is 16 million. 920 divided by 16 million is going to be a very small number, right? Let's plug in 10 million, 100 million, a trillion, etc. And as these numbers get bigger and bigger in the bottom, 920 divided by those huge numbers that get bigger and bigger is going to be, those numbers are going to get smaller and smaller towards zero, right? And so that's going to approach zero. Same situation here. If we're approaching negative infinity, we're going to be having negative numbers that are getting larger and larger in the negative direction, right? So like negative a million, negative a trillion, negative, quintillion, et cetera, right? And as those numbers get larger and larger in the negative direction, we're going to have negative small numbers, but they'll be super small and getting smaller and smaller. So this is going to approach zero, right? So okay, so in both cases it'll approach zero, whether you're approaching positive infinity or negative infinity. If you have a constant on top and an x on the bottom, then you'll approach zero. Okay. All right. So now we have these ones that are kind of modifications, but we can use our sum limit law. We don't have to show our work on, or say that we're using the sum limit law, but we can take the limit of this and the limit of this separately, right? So we know the limit of this, just like we saw earlier, this is going to go to zero, right? And then the limit of a constant is just itself, right? No matter what you're approaching, a constant is going to stay the same. And so so our answer here would be 0 plus 10, which is 10, right? If we're approaching infinity, this will go to 0, and this will just be itself. And so in this case, I think I said infinity, but negative infinity, either way, this will turn to 0, right? All right, so try this one out. Good. If you got that this goes to 0, and so 0 plus 13 is 13, good job, right? So if we go to either infinity with a constant on top and an x in the bottom to some power, then those terms will go to 0.